There is a black hole so large that 100 solar systems could fit inside it. According to physics, it should not exist. 5.7 billion light-years away, inside the Phoenix cluster, sits an object called Phoenix A star. It weighs roughly 100 billion times the mass of our Sun. Black holes are supposed to grow slowly. The universe itself imposes a speed limit. But when astronomers ran the numbers on Phoenix A star, something broke. The universe is not old enough to explain it. By the end of this video, you will understand not just how large Phoenix A star is, but why its existence may mean our model of black hole growth is incomplete. For decades, astronomers thought they understood the upper limits of black holes. Our galaxy's central black hole, Sagittarius A star, weighs about 4.1 million suns. Then came M87 star, whose first image required nearly a decade of global telescope coordination, 6.5 billion solar masses. Then TON 618, 66 billion. Each discovery reset the ceiling. Each one felt impossible until the next appeared. Here is the part your brain resists. The distance from the Sun to Pluto is about 5.9 billion kilometers. Phoenix A star's event horizon spans nearly 590 billion kilometers. You could line up 100 solar systems end-to-end inside the darkness of this single object. At this point, astronomers thought they were approaching the physical limit of black hole growth. They were wrong. Because Phoenix A star is not just bigger than expected, the universe may not have had enough time to build it at all. Black holes grow by feeding, gas falls inward, mass increases. Simple, but physics imposes a limit. It is called the Eddington limit. Feed a black hole too quickly, and the radiation it releases pushes surrounding matter away. The black hole starves itself. Growth becomes self-regulating. That is the theory. Now run the math. Start at the beginning of the universe. Take a reasonable seed black hole, feed it continuously for 13.8 billion years at the maximum rate physics allows. You still do not get Phoenix A star. Not even close. The universe is not old enough. And this is the point where the story stops making sense. Astrophysicist Priyamvada Natarajan of Yale University put it bluntly. Phoenix A sits right at the theoretical upper limit for how massive a black hole can get. Not near the limit, at it, which leaves astronomers with two possibilities. Either our physics is incomplete, or Phoenix A star found a way to break the rules. First, the size itself. If Phoenix A star replaced our Sun tomorrow, its event horizon would extend far beyond Pluto, far beyond the Kuiper belt, possibly beyond the outer edge of the Oort cloud. Not just planets. Entire neighboring star systems would disappear inside it. That would already be absurd. But Phoenix A star gets worse. Scientists currently have two leading explanations for how this object formed. The first is galactic cannibalism. Over billions of years, galaxies collide, their central black holes merge, then larger galaxies merge again. Repeat the process hundreds of times, and eventually you could theoretically build something approaching 100 billion solar masses. But there is a problem. Even the merger models struggle to reach Phoenix A star's estimated mass within the age of the universe. Which leads to the second idea, a primordial origin. Some astronomers believe Phoenix A star may trace back to density fluctuations formed seconds after the Big Bang itself, before stars, before galaxies, before ordinary structure existed. If true, Phoenix A star may be older than every galaxy around it. And not everyone agrees this is even possible. Some researchers argue the mass estimates may be inflated by the extreme environment of the Phoenix cluster. Others believe ultramassive black holes are exposing missing physics in our growth models entirely. Either way, something does not fit. And then astronomers discovered the strangest part of all. Phoenix A star should be destructive. Instead, it appears to be creating stars. Jets of relativistic plasma erupt from the black hole's poles at near light speed, slamming into cold gas throughout the cluster. The expectation was that these jets would suppress star formation. That is not what happened. The collisions compress the gas instead. Stars begin to form. The Phoenix cluster is producing roughly 740 new stars every year. The Milky Way forms about 1 or 2. Phoenix A star is not just consuming matter. It is helping manufacture entirely new solar systems at one of the highest rates ever observed. This is the line astronomers still struggle to explain cleanly. A black hole this violent should sterilize its environment. Instead, it appears to be fertilizing it. Phoenix A star is not a void. It is a furnace, one that destroys everything near it and uses the energy of that destruction to ignite creation across millions of light years. In 2010, researchers working with the South Pole Telescope in Antarctica were surveying distant galaxy clusters from one of the most isolated scientific outposts on Earth. Ryan Williamson and his team were not searching for the largest black hole in the universe. At first, the Phoenix cluster looked almost like a mistake. The X-ray emission was too bright, too energetic, too extreme. The kind of signal scientists sometimes assume is an instrument error before they assume nature itself is responsible. And this is the strange reality of astronomy. You cannot see a black hole directly. You only see what it does to everything around it. To estimate Phoenix A star's mass, astronomers had to reconstruct billions of years of gravitational energy release from the surrounding X-ray brightness. The calculation kept returning the same impossible answer: at least 100 billion solar masses. The team reportedly sat with that number for a long time, because numbers like that are dangerous in science. Sometimes they reveal discovery, sometimes they reveal broken assumptions. What makes Phoenix A star unsettling is not just its size. It is the possibility that the universe built something our equations say should barely be possible at all. In 2025, NASA's James Webb Space Telescope directly imaged the cooling flows inside the Phoenix cluster for the first time, helping explain its extraordinary star formation activity. Future X-ray observatories, including the European Space Agency's New Athena mission planned for 2037, are specifically designed to measure ultramassive black holes more directly. Phoenix A star will be one of their primary targets. But the core questions remain unresolved. Did Phoenix A star grow through endless mergers? Did it begin forming before the first stars existed? Is 100 billion solar masses the true upper limit for black holes? Or have we simply not found something larger yet? Astronomy has faced moments like this before. In 1998, scientists tried to measure how quickly cosmic expansion was slowing down. Instead, they discovered dark energy. The universe has a habit of answering questions by breaking the question itself. There is a black hole so large that physics struggles to explain how it exists. That was the claim at the beginning of this video. Now you understand why astronomers take that claim seriously. Every generation believes it is approaching the edge of knowledge. Then the universe reveals something larger, something stranger, something that forces us to redraw the boundary again. Phoenix A star exists at the edge of what modern astrophysics considers possible, and it may not even be the limit. The universe does not care what we expect to find, it only cares what is true.